You know that old saying, practice makes perfect? Well, in the world of AI, it turns out that practicing too much, or on the wrong stuff, can be a huge problem. We're going to dive into this really fascinating idea called overfitting. It's where an AI gets so good at its practice material that it completely bombs the real test. So what's really happening under the hood? To really wrap our heads around this, let's start with a kind of a weird question. What on earth do a bad student and a bad AI actually have in common? It sounds a little strange, I know, but the answer really gets to the heart of what it means for a machine to truly learn, instead of just memorizing. Okay, check this out. On one side, you have the student who actually gets the concept. They understand the why behind it all, so when they see a new question on the real exam, no problem. Their knowledge is flexible. But on the other side, you've got the student who just memorized the answers on the practice test. Their knowledge is totally rigid. The second they see something new, they're lost. And that right there, that is the exact same trap an AI can fall into. So this whole thing, this memorization problem, it actually has an official name in the world of machine learning. And it's not just some quirky little study habit, it's a major issue called overfitting. So here's the official breakdown. Basically, an AI aces its homework, the data it trained on, but then completely flunks the final exam, which is, the real world. And that last part is so important. It has memorized the noise, not learned the signal. What does that mean? Well, think of the signal as the core concept, the actual pattern you want to learn. The noise is all the random, irrelevant little details. An overfit AI gets obsessed with that noise, thinking it's the important part, which makes it totally useless when it sees new stuff. Okay, so if this is such a big problem, how do we fix it? How do you stop an AI from just cramming for the test? Well, the first batch of strategies is kind of funny. It's all about this less is more idea. It's about giving the AI better study habits.
And yeah, this isn't just people throwing stuff at a wall to see what sticks. Data scientists have a whole bag of tricks, a toolkit full of really clever strategies to fight overfitting. So let's jump into a couple of the big ones. First up is this idea that is just brilliantly simple. It's called early stopping. So the model starts training, right? And its performance gets better and better. But then it hits this perfect little sweet spot, the moment of peak performance. And that is the exact moment before it starts going off the rails and just memorizing all the useless details. So what do? You just stop. You pull the plug right there before it gets too smart for its own good. It's literally knowing when to close the textbook and say, all right, that's enough.
Okay, then we have a couple of techniques that are all about helping the model focus. One is called pruning. It's like being a good editor. You just snip out all the irrelevant details, all the fluff, so the AI can concentrate only on what's actually important. Then there's regularization, which is also super clever. It basically tells the model, hey, don't get too complicated. It adds a little penalty, almost like a tax, every time the model tries to rely too heavily on one specific, complex detail. It forces the model to keep things simple and look at the bigger picture. But wait, it's not all about simplifying and cutting things down. There's a whole other way to tackle this, and it's all about teamwork, about strength in numbers. This is really cool. Check it out. This whole approach is called ensembling, and it works kind of like getting a second opinion. So imagine you've got a really simple model, what we call a weak learner. You show it a picture, and it goes, yep, that's a cat. Then you ask another one. It looks, and it also says, cat. Okay, 2 for 2. We're feeling pretty good about this. But then you ask a third one, and this little guy says, no, I think that's a dog. So now you've got a disagreement. Who's right? Well, the answer is just simple democracy. You take a vote. 2 said cat, 1 said dog. Majority rules. The final answer is cat. And by doing this, by getting a bunch of simple models to vote, you smooth out the weird individual mistakes and end up with a way more reliable answer. It's pretty genius, right?
And last but not least, we've got something called data augmentation. This is another one of those why didn't I think of that idea. Instead of just showing the AI the same photo of a cat 1,000 times, you mess with it a little. You show it a version that's flipped upside down, one that's turned sideways, maybe one with the brightness tweaked. It's the same cat, but it looks different. And what this does is it forces the AI to learn the essence of catness, It has to understand the actual patterns, not just memorize one single perfect picture.
So when you pull it all together, early stopping, pruning, all that teamwork with ensembling, data augmentation, all of these different strategies are all pointing in the same direction. They're all trying to achieve one crucial thing, what's called generalization. And this quote right here, it nails it. A model that only knows the past cannot predict the future. I mean, that's it, right? The goal isn't to get a perfect grade on an old test. The real goal is to build something that's ready for the wild, messy, unpredictable real world. It's not about being perfect in a simulation. It's about being useful out here with us.
And that really brings us to the big final question we all need to think about. Because AI isn't some far-off sci-fi thing anymore. It's helping doctors, it's driving cars, it's everywhere. And when the stakes are that high, the difference between an AI that's just memorizing and one that's truly learning, well, that's not just a technical detail. It's everything. Figuring out how to make sure these systems can generalize is, without a doubt, one of the biggest challenges we have if we want to build a future with AI that we can actually count on.